Rosiclare. Here live the men and women whose daily work makes possible the mining and milling of Fluorspar, the substance from which synthetic cryolite is made. Rosiclare played an important part in winning World War II, since it is in the heart of the Illinois-Kentucky Fluorspar district, which produced about 80% of the whole world's output during the war. These Alcoa people are specialists in the field of hard rock mining. Each knows his job and takes pride in doing it well. Some of these men are working at the job of prospecting. They drill deep into the earth to locate fluorspar deposits. To do this, they use a hollow drill with a diamond face. As the drill cuts through the rock, water, forced through the hollow center, cleans and cools the diamond cutting face. Then the drill is removed and the core is examined by a geologist to locate ore that can be mined. Underground core drilling is much the same operation. It reveals additional ore deposits in the mining area. The head frame supports a man hoist, so the miners can descend to the several levels below the surface where the actual mining is going on. This level is located 700 feet below the surface. Since fluorspar veins run through limestone and sandstone, haulageways or drifts of sufficient size must be driven along these veins to permit passage of men, supplies, broken ore, and rock in cars. These drifts are extended with a rock drill operated by compressed air. Water washes the cuttings from the drill hole and prevents the formation of dust. After the holes are drilled, the powder man takes explosives to the face. Incidentally, dynamite, caps, and fuses are never transported together. At the face, the dynamite is placed and tamped with a wooden rod to avoid danger from sparks. The fuses are timed to fire the holes in the proper order. The interval between shots is small, just long enough to make sure the ore breaks the right way. When the charge is placed, the fuse is cut long enough so the men can be in a safe place or out of the mine entirely at the time it blows. And at the end of the shift, it is lighted, and then between working shifts, blast fumes are removed by a fan on the surface. A machine called a mucker then mechanically loads the rock blown down by the previous day's blasting into ore cars. After working space has been prepared, timbering is put in to form an overhead floor. Now the mining operation called stoping can begin. Stoping is the process of working upward along the vertical vein of spar. Manways are constructed approximately every 100 feet. These are service entrances for water, airlines and material, and working space for miners. Chutes are constructed on each side of the manway so that the surplus broken ore can be taken from the stope and allow the miners plenty of working space above. The miners then begin to drill and advance upward to the next level. After the ore is blasted to the false floor, it is dragged to the chute by a slusher. This method of mining is known as modified shrinkage stope mining, or the process of working upward. An electric battery-driven locomotive brings the cars to the loading chute. The broken ore blasted from the stope is loaded from the overhead bin into these cars. The most modern in the field, each car holds 2 1/2 tons. They're pulled along the drift to the skip pocket, a large bin hollowed out of solid rock. Two skips, each holding 2 1/2 tons, hoist the ore to the surface. The loading, raising, dumping, and lowering of the skips is automatically controlled. This modern equipment is capable of bringing as much as 600 tons of ore to the surface per shift. In this method of hoisting ore, one skip is being loaded as the other is automatically being emptied. This is called hoisting in balance. After the ore has reached the surface, it is drawn from the bin at the head frame into trucks and is hauled to the ore storage pile in the mill yard about a mile away. To maintain an accurate check on the flow of crude ore from the mine to the mill, each truck passes a check station and a weighing station. At the mill storage pile, the ore is dumped in successive loads from one side of the pile to the other and back again to obtain a good blending. It is sampled periodically during the day so the mine foreman knows the quality of the ore. It is taken from the storage pile by a dragline scraper hoe, which drags it to the apron conveyor, which in turn feeds it into the hammer mill, where it is crushed into pieces less than 1 inch in diameter. A conveyor feeds the ore from the rough storage tank into the mill proper. Fluorspar shatters more readily than does the waste or rock, so that a simple screening process recovers a considerable amount of fluorspar, and other processes such as flotation reject most of the remaining waste. A screw classifier further separates the ore. Then the ore goes into the sink float process. It is dropped into a mixture of water and finely ground solids in which the rock waste floats while the spar sinks. This method would be comparable to separating sawdust from sand in water. In this overflow channel, the rock is floated away. The remaining minerals sink to the bottom of the cone where they are taken off. The liquid used in the sink float process is continually sampled to be sure that its specific gravity is great enough to float the rock. After leaving the cone, the waste comes down the left-hand side of the screen and the fluorspar down the right. This separation is about 95% efficient. The waste rock is rejected and the water mixture is adjusted for density and returned to the process. The concentrated fluorspar is conveyed to the ball mill to be ground to 65 mesh for feeding to the flotation cells. From the ball mill, the ore is sent through a rake classifier where the fines are separated from the coarse, which is returned to the ball mill for further grinding. The fines are now advanced to the flotation cells. Reagents are added to the first series of flotation cells to float the sulfides of lead and zinc. In the flotation cell, the sulfide minerals form a froth on the surface, which is removed by paddles. A rotary filter removes most of the water and leaves a moist concentrate which will be sold as a byproduct. Reagents are again added to the flotation process to get maximum flotation of fluorspar. Here again the froth is collected by the paddles. The flotation is repeated 3 times to yield a substantially pure calcium fluoride. The final fluoride concentrate arrives in solution at a large rotary filter. After the moisture is removed, the spar is elevated to a storage bin. During this process, the mill has taken a crude ore containing from 35 to 65% calcium fluoride and has produced a final product with a purity of 97 to 99%. The damp concentrate must be dried and ground before it can be used. From the bin, it is fed by conveyors to the dryer, which consists of a shell with steam tubes on the inside. After drying, the spar is fed to a ball mill, which reduces it to a very fine powder. This extremely fine grinding is necessary to meet the requirements of the East St. Louis method of producing hydrofluoric acid. Then the spar is separated by air. The coarse is returned to the ball mill for further grinding. After the final grinding, the fluorspar is loaded into railroad cars to be shipped to East St. Louis for further use in the reduction of aluminum, in the production of aviation gasoline and refrigerants, in hydrofluoric acid, laundry bleaches, insecticides, fluorine salts for the prevention of tooth decay, and many other ways.